product. It covers a lot of different solutions. Today we're going to be covering a few different things, for instance, the irrigation control and monitoring, and it ties into the whole system of ranch monitoring. So what we're going to be covering today is a few different things. So we won't be covering all of the 6 solutions, but primarily a focus on the alerting and the irrigation and equipment control, as well as tank and pond monitoring. And so as we begin today and you have any questions, feel free to write them down or put them into the chat dialogue, and we'll answer those at the end of the presentation. So as you go forward with this, just think about the different scenarios that you may have and any questions that you may have along the way as well. Okay. So the irrigation system monitoring entails quite a full breadth of information. Most importantly, when monitoring the irrigation system, flow performance and usage is entailed with our system by enabling the user to record real-time flow rates so they can log into our system and see the actual flow instantaneous, and then applying formulas to get the cumulative volume and, for instance, the gallons per day, the gallons per hour, and so on and so forth. And all this data goes and feeds into our alerting mechanisms, which can provide these important alerts for over and under flow conditions, as well as other scenarios as well. But this is also very crucial for reports. This can be used for weekly and monthly meeting reviews, and as well as submitting to water agencies in an automated fashion. The other things that we'll be covering here as well will be the system pressure and block pressures, and how the nominal operating pressures can be an indication for sensors that are out of range when you're performing irrigations, and also feeds into that alert mechanism for dangerous conditions. Along that same note, water supply monitoring and its importance is very crucial, because that's what's being delivered to the field. And with ranch systems, you can monitor a variety of things, including your well and the tanks, for instance, for pH, acid tanks or water tanks, and you can monitor the mainline water quality with, for instance, the pH or the EC, and a variety of multiple sensors that can be utilized to get more of an idea of the water quality and how it's being applied to the field. So all in all, the system for irrigation system monitoring is one in which you can collect the data and use this for a variety of ways. And with ranch systems, you can tie all these the methods together and ultimately reduce your infield man hours. So the advantages of comparing flow rates in real time is that your instantaneous readings are not always accurate. For instance, if you're standing in front of a flow meter and you're looking at a gauge, you may notice that, as you can see here in the graph, when the valve is opened up, we have an inrush of up to 200 gallons per minute. And then after about 5 minutes, you see that it settles down to 150 gallons per minute, and with some spikes in between. So with using the ranch system software, we provide the visual interface for all these data points in a way in which you can visualize this in a more meaningful way. So what we are looking at here is, in this graph to the right, we have a valve activity down below, and you can see the inrush and then the stabilization with a couple of peaks and valleys in between. And then a second valve opens here, and you'll see an inrush as well. Now this is the mainline flow, and this is very important to note that while we have a mainline flow meter, this is a good indication of the system performance. It's also very important to note what happens in the block. So specific blocks and the flow rates in that block, and having flow meters and equipment in that block will provide more meaningful data. But as you can see, there are some variations in the data here, and being able to visualize it provides a better key to the system performance and how its overall operation is occurring. Now, by looking at this data, we notice that the 150 gallons per minute is the nominal flow rate for this one block here, which is the water valve number 1 in this case. And 150 gallons per minute is the nominal rate. So if we have, after 10 minutes, so after this spike, if we have somewhere outside of this range, that can be used as a tool for alerting a user in various ways of a degradation in performance. And that can also be used to alert a variety of people, for instance, irrigators or managers, to be able to address that issue in a meaningful way, in a timely way, so that continued waste of water, one of our most crucial resources, can be addressed. So this can be seen not only from your computer, but it can be addressed in the field if you're on your phone. There's a variety of ways to view this data. One of those is in front of your computer. The other is via your mobile browser on your phone. You also have a text messaging interface, so that you send a text message, you can receive the real-time flow rates or even the average flow rates. And also there's a voice system as well. So we'll be covering that at the end of the presentation. But there's a variety of ways to get at the data, so you don't always have to be right in front of the computer, or right in front of the equipment, rather. So with the water supply monitoring, the very interesting thing about the water supply is that supply changes, as does the rate of application in most cases. So when you're using well water, municipal water, tank, it's important to keep an eye on the quality of the water. And many times when you're using a well for the supply, it's important to note what the water level is in the well, and there's various sensors that can be used for that. In this case, we have a graph to the right, which is of the water level from the surface to the water. So this is negative 65 feet here, and this is just a very simple view of this data. So you can see here that we have an irrigation event that's occurred. You don't see the irrigation valving underneath, but this is just to illustrate the point that as soon as the main well is turned on, you can see that the water level drops in the well and significantly comes down. And this can be used to alert the user of any issues, of various things. And we'll be showing these a little bit more in detail at the end, while we'll be looking at the graphs. I just had a little slide issue there. Hold on a second. There we go. So then with tank and well level monitoring, this can be accomplished in various ways. If you have an acid tanks or water tanks, there's a variety of ways of performing these measurements, for instance, ultrasonic or with a pressure sensor that actually has contact with the material. But alongside with this, having the data as a historical relevance, you can see what happens during irrigations and after the water is being applied. In this particular instance here, we have the acid injection, and we have a pH starting at around 6.5. And you can see what happens over the course of a few hours, that you have a significant change in the pH as various valves are opened and closed. And then we have down below the sulfuric acid tank measurement. So this is 4,017 gallons, and then you can see it dropping as it continues to run. Now this can be very useful for a variety of ways, and one of the things to think about when you're thinking about how to use ranch systems is every single data point, even the time is a data point, can be used for a variety of ways, and we like to be as flexible as possible and remain open to what the user's needs are, and we accommodate that at ranch systems and try and make the system as most intuitive as possible. So if you see anything here that may trigger an idea, it's a good idea to write it down and see if it's something that we already do. but most of the time it's something that we can work with and make as a function for our system for you. So with irrigation, the way we look at data in irrigation, when you look at the flow meter in the field, if you have one already, you'll notice that you have an instantaneous reading. And the instantaneous reading will tell you the gallons per minute at that second. So what Ranch Systems is doing is capturing that gallons per minute in a regular sampling interval. That can either be by actually counting every single pulse or by just simply measuring it in an averaging function. And so by doing this, we can see here the green spikes here. These are gallons per minute spikes. And you can see it's around 275 gallons per minute to about 250 gallons per minute. And by using this in conjunction with the valve activity, we can deduce things like the applied volume per plant. It can be configured and changed via a simple mathematical expressions to change the unit of measurement. You can basically do anything that you like with this data. So while alongside looking at real-time data, you can get calculated values, and these calculated values can be manipulated by you, the user, or any of the consultants that you work with, and the system is very flexible to do that. So in this particular case, we've got the valve activity, and you can see down below a little legend of the color graph above. So we have at the very top we have the air temperature, and you can see the fluctuation in air temperature. And then we have the block A2 flow in gallons per minute. You see these spikes. And then just below that you can see these calculated values, which are basically telling you the gallons per vine in the last 24 hours, which is the blue line, and the gallons per 7 days. And you can see how we have 2 irrigation segments in a similar time period, so these are within 7 days. And you can see that the gallons per vine over a week has increased slightly here. And this can be used for reporting purposes and also to compare with any soil moisture measurements, etc. It becomes a very useful tool, especially when looking back at the end of the year and seeing what the yield was and how the application of water affected that in various blocks. So one of the ways that we work with the data that we were just mentioning is the instantaneous readings can be a little bit off. So we measure over a period of time, and you can see in this particular instance we have a valve that has been opened. You can see that here is the green line, and the blue line is where the valve has already been opened. So the green line here is when it goes from 0 to 1, that means that it's been opened. It kind of looks like a little square wave. So this here is actually valve activity. And you see here right when the green line opens, about 10 minutes later to 2 hours later, it reaches its maximum flow rate. So it's got a very low fill rate for this particular block. And then what we've also done concurrently with this is that we've created a model for the customer so that they can see exactly what is going on with the system in proportion to what they'd expect. So we know by working with users that they have a certain expectation of their irrigation system. And so this is a very good example of a performance curve. So in essence what we're doing is that these valves here, as they turn on, become an indication for when we need to start analyzing the flow for a particular block. And then the grower has inputted their gallons per minute for each of these valves into the system, and it has produced this graph down below. So what we know is happening here is that with the opening of this particular valve, that there's an excessive flow to this block over a period of time, and you can see that that's in the thousands of gallons. That can correlate to a lot of waste. This is an averaging function over a day, so we know that in this period of time about 10,000 gallons were excessively applied, and that can add up over a period of day. And then here we also have another little blip. So this can be used by irrigation managers to know when they have an issue with a particular block. Outside of the normal irrigation alert feedback, which tells us if there's overflow or underflow, these pick up the subtle variety in the data and creates an analysis that can be used on a higher level to see if there's an issue. For instance, clogged emitters. You can see here we have a somewhat of a negative integer just below this origin line here at 0K. This can also be used to see if there's blown emitters or blown pipe. For instance, here we have a blown pipe here. And so we know that this is a particular alerting issue, but it also provides some more historical relevance to where the water went and how it was used. So the next thing is that this data can feed into reports. We have here a report. It's a little bit blurry, but you can see that it has the customer's logo, and then it has the days of the month, every month, and then the day of the month in the vertical column, so that he can tell the exact gallons that have been applied in each month, each day, and then cumulative for the whole year. And this can be used for any range of reporting. It can be used to send to water agencies. It can be used for the weekly irrigation review, introducing irrigation management. It can be automated, so it sends it as an email. It can send it to a server. It can also be available to download in various formats in the online software as well. So here we have a little bit more of a variety to the presentation. This is the hardware aspect of how the irrigation can be controlled from an upper level of management. So we've talked, lower level of management. So when we look at some of the monitoring provides us with the real-time data, the actual health and status and performance of the system, the irrigation system, or anything else for that matter. But when it comes to actually using this data in a larger way, in a more distributed way, one of the things to consider is actually switching pumps on and off and controlling the actual flow of data and not just monitoring it. So there's a variety of ways and systems to control irrigation. One of the most common things in a field is an electric pump, whether be that a well or a booster or anything for that matter. So there's two generally accepted ways of controlling pumps as they are. One of those is the contactor with a low voltage switch, and this acts as a relay. And you can see here for this picture we have this large gray box, and right next to it we have a booster pump and a well. And so inside of this box here we have a low voltage control circuit that's been installed by a certified electrician. And what that does is it connects to our unit here, and the unit will send a closure signal to the electrical components inside of this box that then works with the higher voltages and opens and closes the circuits for turning on these pumps. And right alongside of that you can see a flow meter here on the ground for getting some feedback. The other, now this is many people would say this is kind of the more basic way of controlling an electric pump. That being because it's just a simple switch. There's not much data that comes back from this mechanism as the pump gets turned on. That's a data point. And so other sensors are required to know if this is actually on or not. The other acceptable way of controlling an electric pump, but requires a substantial more investment, but you may already have this, is a variable speed frequency drive, or VFD for short. And what that is it looks very similar to this. However, it provides the entire control mechanism, so you can change the set point or the PSI that you would like to hold the system at, and it adjusts the frequency of the pumps or motors to match that PSI. So as you have valves that close and other valves that open, it adjusts the frequency and actually turns the pump on and turns it off in proportion to demand. And that particular system, when it's enabled for Modbus interfacing, which you can ask Ranch Systems about later if you have any questions, or your reseller, that provides a lot more information to the user because it has a serial interface which can be used to turn on and off the actual drive itself. But it can grab the pressures, it can grab the frequency, the voltage, the amperage, and those can all feed into the models for deducing the kilowatt hours of a pump, or the kilowatt hours outside of peak hours, for instance, and it can help you optimize your irrigation plan efficiently. The other way of controlling your irrigation system, which is diesel pumps and generators, generally speaking, are with auto start systems with an input capable controller. For instance, just like the electric start and stop, this is a relay, which is a switch in a sense, and when this switch is turned on, the engine will run, and it's turned off, the engine will stop, and the controller, the auto start, ramps down the pump and does everything that needs to be done. That's the most basic way of doing this. The other way, which is also a little bit more expensive but provides more information, is the Murphy controller, such as the EMS Pro or the EMS Lite, and that's operated with the Advanced Communication Interface, which is the RS-485 Modbus, and that provides just more detailed information at a higher level. So you see things like the RPM, the oil pressure, the running hours. You can even see if the system's been turned on manually, and you can turn it off remotely as well. So once the supply has been controlled, the next logical control is the solenoids and the block valves. So block valves, most people are familiar with these valves, but just in case, these are valves that have a diaphragm at the top and can be pulsed with energy to open and close the valve for flow. Many people are familiar with gate valves or ball valves, which manually need to be turned. However, these are not controllable by Ranch Systems due to the fact that it needs an electrical signal to be able to open and close. So one of the ways that most growers go about doing this is equipping their existing valves with DC latching solenoid or a normally open solenoid. Now there's two advantages to doing a DC latching solenoid. One is that it requires less energy and can be verified as open with a signal as well. And it does not require an on-site power supply. So there's two different forms. One is this normally open, and the normally open is generally a 24-volt AC normally open solenoid, and that requires on-site power supply or transformer, which should be installed by a certified electrician. So it requires a little bit more equipment in the field, and there's a little bit more of a possibility that there could be an issue with that control. So generally speaking, we recommend if a new system's being put in to go for the DC latching solenoid option. It doesn't require but a few more dollars, but it can go a long way in the performance of the system and directly interfaces with our equipment. So once a pump has been turned on or a block valve has been turned on, Ranch Systems likes to check with the data to make sure that there's some sort of feedback. And the way we think of this is just a simple question: did it open? So with our system, you can pulse a valve open and close, but it's very important to get some sort of correlating data to indicate if that valve is opened or not. And one of the ways to do that is with a feedback sensor. That can be with flow meter, pressure sensors, but it's all dependent on the system and how it's laid out. Many irrigation systems are quite complicated, so it's always a good idea to review this with an irrigation planner or with your in-house irrigators, just to make sure that there's no page unturned, so to speak. So things to consider is when the valve opened, how do you know that it's opened? So there's flow into that particular block. Is there multiple valves after that block? So there's various ways of accomplishing this, and it just depends on how much of a system you want to incorporate. And this can be scaled infinitely to provide a very detailed analysis of the system. The other thing about a system is that once a pump is turned on, how do you know it's operating normally? The pressure, the flow rates, energy consumption, those are all things to consider regarding the health of the system. And then the other thing is who gets the alerts and how. So are these irrigators that should get the alerts? Do they prefer text messages or email? All these things can be accomplished with our system. But before you get started with it, it's a good idea to understand who's going to get those alerts and how they're going to get them. And then we can bring more to the table for you. And what else should I think about? There's also a good idea to take into mind that while our system is an automated approach to controlling irrigation, a manual in-field physical damage control, if anything should happen to any equipment, is always a good idea. So when you're building this, pressure relief valves are very important. Pressure sustaining valves or VFDs are a very good idea. But it's a good idea to discuss these with an irrigator or a planner so that you can have the proper shutdowns and mechanisms in the field so that no damage can occur. And then we can provide the alerts for that. So the system indicators in the feedback is, for instance, here we have a block valve that's opening up. And in this particular instance, this is a well that's being controlled. And this particular well has been very troublesome for a number of reasons. One of those is that there's a manual switch in the field, and many times the grower will go out and turn it on manually to fill something when it's outside of the normal hours. They don't want to go to the top of the hill to get water, for instance, and they want to get water at the bottom of the hill, so they turn it on manually, and they may leave it in the off position. So one of the things that we're looking at here is actually the amperage that the motor itself is consuming. And you can see down below where the control is being issued to this particular pump, and you can see how it's being turned on and turned off and the corresponding amperage that this motor is consuming. This is a Hall effect sensor that's installed by an electrician and provides us a 0 to 5 volt signal corresponding to the amperage. And it's a very good indication of health of a pump alongside with the pressure and flow. So all these things together provide a very comprehensive view of the system. The other thing that we've done as well is we know that in this particular instance they have a water level sensor at a tank, and they would like to irrigate during the day and have this tank refill. So what we do is we automate the refilling of the tank and the irrigation system there. So what happens is when the water level drops to a certain level, then the pump is turned on, and you can see that the pump is turned on and it starts to fill the tank. But what we've also done is we say that if the water level is low, that there's a demand for the system, and if the valve is turned on and there's no amperage coming from the system or no flow, we use this as a way to indicate here with this new sensor down below, which is the pump off when needed on sensor that's been configured manually. This tells the grower statistically how many times a month that there's an issue, if there's something that they need to discuss with their irrigators about managing and turning off switches and so on and so forth. This is also just round robins back into how we do irrigation feedback. So This is a visualization of the feedback that we do as an internal check, and we'll talk about that in just a moment, how that actually works. But the important considerations to verify that the actuation occurred is flow to a particular block, the pressure in that particular block, and the pump generator status. And a combination of these three will provide you a very comprehensive view of the performance of any system. So let's talk about how and what kind of sensors that might be. So flow meters can be installed in the main line. They can also be installed out in the blocks. Right here we have a picture of a flanged flow meter from NetFM, and the output register on the top, which interfaces directly with ranch systems with the correct output. So you can have different pipe sizes, you can have different flow rates, different pressure working pressures. They're available in a variety of different styles. One of them is flange, like we see here, or an insertion meter, which actually you have to cut a hole in the large diameter pipes and put a saddle around the outside of it. And then there's also some newer ones that are called ultrasonic or mag meters that actually attach to the outside of the pipe, or also work as an ultrasonic mag flange meter, and they have no moving parts, whereas the two top ones here typically do. So the things to consider when you're looking for a flow meter, we need to know the pipe size, the flow rate, the working pressures, and also an idea of the water quality. If it's pulling directly from a river, for example, and there's large particulates, it's a good idea to take that into consideration, because large particles that are passing across the flow meter mechanism can damage it internally. So it's a good idea to keep that in mind when you're considering what kind of flow meter to use, and that you choose the specific flow meter according to how it's going to be used. The other thing we talked about are pressure sensors, and they're installed typically with this sensor here is a pressure sensor in the sensor cable coming off of it. And you'll see that we have a male pipe thread, and this is a 1/4 inch male pipe thread. It's very similar to the gauges that you have out in the field, the visual gauges, except it doesn't provide the visual output. This is merely an electrical signal. And this can correlate to the PSI or the KPA of a system. And they are typically installed near your existing gauges or visual gauges so that they can be viewed while you're in the field and you have a correlating data point online, so you know roughly what's going on in the field. And pressure is always a good indication of the system with the combination of flow. And the reason for that is that the flow rate can be fixed at a particular rate. For instance, if you have a VFD or pressure sustaining valve, the pressure may stay at a fixed rate where the flow may start to increase, or vice versa. If you have just an on-off switch for your pump, the pressure may drop while the flow rate remains the same. So this performance curve that we were talking about earlier can be used as modeling the performance of the system and combining two sensors to provide a better performance curve or feedback mechanism. So imagine that you have a pipe that's broken, and that pipe is a drain for a lot of water, or an output for a lot of water, and that can drop the system pressure. So we would monitor the system pressure with a pressure sensor, and then the mainline flow or the block flow meter, and this could be used to send an alert of a broken pipe condition or something to that effect. So alerts are very configurable in the online system. They can be sent via text message, phone call, or email. You can select multiple recipients, so they'll be just separated by a comma. We have an acknowledgement system, so after you get a text message using the rules and alerts in the online system, you can also set an acknowledgement timeout, so that the period of time that we expect to get someone to pick up and say, I've got this. And if nobody gets a particular acknowledgement or issues an acknowledgement of an alert, we can repeat the messages if there's no answer. So some samples of flow alerts or feedback alerts would be the flow rate being outside of a normal range, for instance, too high or too low. This could be per minute, hour, or day, so you get longer intervals, and perhaps the more granulated approach to looking at the data as we were looking at earlier. You can also get alerts for excessive current from the electric pumps, excessive kilowatt hours, amps, volts. These all tie together. They're basically the same, but it's just a different way of looking at the data. Pressure spikes, so you can get an alert for the PSI or the kPa if it's above a certain value or below a certain value, that can be as well. And then most importantly, if a valve is opened and there's a delay of the feedback, so if it is outside of the normal range, for instance, low or high, if it's delayed, we think of that as a low reading or outside of the normal range. So if a valve is sent the open signal, we check to make sure that that data point comes back that the valve has actually been electrically charged. Then we look for the flow or the corresponding feedback, and if it's outside of its nominal ranges within a certain period of time, we can send that alert as well. So we have a sample alert here that just says the flow in block A1, and then typically after this we would have a unit ID, and then it would give you the actual gallons per minute or whatever that sensor's unit of measurement is and what you would expect it to be. So while we talked about a little about the systems, management of the system, the different components, let's talk about ranch systems hardware, just because that is the building block of getting a great irrigation system. We're going to be looking at the system layout and building the best telemetry for your system and understanding how they connect together to give you a robust controlling equipment. This is a ranch systems farm, or a farm that a grower has. This is just a representation of that in an illustration. And you can see here we have a few different vines, an irrigation system over here to the side, and drip tubes, or otherwise IPS in the field, delivering water to the vines here in this image. And then over to the side we have a pond and a controller for that pond that's sending it over to the system, as well as some tanks and so on. So the typical way without ranch systems is that a grower would have to come out and make sure that the tanks are filled up, that the water level in the pond has sufficient water level, turn on the pump only after making sure that they opened the block valve first. If they didn't, then they'd have to come back over and make sure that was open, and then come out and make sure that all the water levels here, or all the flow rates to each emitter was correct. There's no broken T's or pipes, nothing separated, everything looks good. And then going back to the house to get lunch and finding out 2 hours later that the pump had turned off. So large irrigations could be missed and time wasted very easily that way. So with ranch systems, we take a novel approach, which is to provide the real-time data and to also give the alerts to that. Here we have a ranch systems RM210, which is the center connection for, or the central hub for all the telemetry equipment. And one way to think of this is the gateway, or the way in which the data comes from the field into the online software. So you can see here we have a little connecting line over here to the cell tower. Now the cellular connectivity for ranch systems equipment is crucial, so a good signal is important. Making sure that you have signal in your cellular device, like a cell phone or something to that degree where you can verify that you have signal, and if need be you can install a directional antenna to boost the signal a little bit, but if there's no signal, something else needs to be decided as to the way to do that. Once this data has been sent out to the cellular network, which is the way that this unit connects, then it is sent to the cloud, or to the ranch system server, where the data is stored. And then this gentleman here in his house can then connect to the ranch systems server in the cloud and look at the data that he has stored in the cloud. And the advantage of doing this approach is that no longer is the user's machine susceptible to issues that could hinder the operation of the performance of the system. It's all operated in the cloud, so if you had any computer issues, you could just keep working without having to worry about why there's a computer issue or something happening to that computer. You could just pick up your phone and start operating again. And so you can do this on a variety of mobile devices as well. For instance, this is a tablet. You can do it on a tablet or a cell phone. As you can see here, this grower here by the truck here up at the corner. So now we start to look at what happens in the field. We know that the data can get out of the field, but there's a variety of equipment here. And one of the things that you might think about is that the irrigation control is probably the most foremost important thing on the system and the livelihood of this crop. So here we have an RS300 that's just placed nearby the valves here. And you notice that we have a good clear line of sight. There's nothing impeding that signal. There's no hills. But in the situations where you do have hills on the system, it's a good idea to review that with a reseller or wrench systems just to see if there's any sort of telemetry that might be more advantageous to take advantage of the signaling and make sure that there's good connectivity. So while an RS300 could be a slave or a dependent of the RM210, it can also operate as an independent piece of equipment. So this connecting line indicating that the data path is going back to the base station. It could also go directly to the cloud as well, or to the cellular network. So we have one RS300 that's controlling block valves and monitoring the flow rates, while another one has just been shown up here as well that's going to be connecting to a wired AquaCheck probe or soil moisture probe. And there's a variety of sensors that can connect into the units, but this just gives you an idea of how this system works. You'll see here that a camera has just appeared to the side of this RS300. So you have a variety of other add-ins as well. And one way to think of it is that every RS300 or RM210 has a variety of options. And while you might just be using it for flow or irrigation control, but you can also upgrade the equipment by simply plugging in or adding more equipment to it. It doesn't require a whole new piece of equipment anytime you want to add a new system in or a new functionality to it. And the firmware can most likely be updated over the air or with a cable, so you can stay abreast to newest changes or improvements in the software in a very high-tech fashion. So here we have the tank monitoring. And you'll see that we have this unit connecting to the water valve unit. So if it was too far, for instance, if it was unreachable directly by the base station, there is the possibility of setting up what's called a multi-hop network. Though we typically advise to design the system in the most robust way in which the base station becomes the direct point of communication. In case there's any issue communicating with this unit here, for instance, if it gets removed for service or it gets damaged somehow, you still want to be able to get the data from this far node. So it's a good idea to try and plan in the best case scenario that you can reach directly to all the units and possibly consider using more base stations to accomplish that. Then we have another node here that's just, monitoring the water level here. So all in all, our system at this point is now fully automatable. So the grower can now focus on other things, and instead of running around and manually opening these valves, can now focus on the performance of the system and saving water and saving energy and ultimately time. So a little bit of a discussion on the RM210. This is a base station. You may be already familiar with it. The server connectivity to the cloud can be with a cellular or Wi-Fi, but it's not recommended for irrigation control, though it is listed as an option. There's a variety of options for charging the internal battery. One of those is solar. You have a 20 or a 50-watt solar panel, and you can use a power adapter. So we typically recommend the solar option in all or most of all installations, where the power adapter is susceptible to spikes and energy issues. So it's good to have it kind of disconnected and using solar panel where possible. But in low light conditions where you have power available, an electrician has an outlet installed, then power adapter is a good option. And then you have a variety of options for the radios. Basically, these just depend on the terrain and the distances that you would like to cover. So from the top down is the order in which the signal is propagated, and we have our best one here, which is the 915 megahertz 1 watt. Substantially more expensive, but really great range and can work in areas where there's lots of canopy and hills, for example. And then we have a bulkhead here, which is basically a screw that allows you to extend the antenna to increase the range. So inside of this unit, it has an integrated 12-volt, 20-amp-hour battery, but you can optionally upgrade it to a 55-amp-hour, which is a much larger battery, but provides up to a month of runtime in the absence of sun. So the general function of an RM210 is it's the hub for telemetry nodes. It's the gateway to the online software for that equipment, so it can send the data. And it also serves as the monitoring and control unit, and you can plug in various sensors into it. So while it does serve as a gateway, it does have the full functionality of a telemetry device and sampling device, so all the various sensors can plug into it. So this is what the underside of a RM210 looks like and all the ports that it has. You'll see here that we have the analog digital inputs. These can serve for a variety of different sensors, for instance, temperature, relative humidity, flow, pressure. Then we also have a rain gauge that could be plugged in, or a digital input. And moving in the other direction here, we also have an RS-45 or STI-12, which could be used to monitor soil moisture, control valves, or even VFDs, for that matter. Then also up here, a little bit up more, would be the RS-232 interface, which you can use to control, as well as take pictures with the camera. And then lastly, we have the charger input. So this is what an RS-300 looks like. We have server connectivity options, cellular, Wi-Fi, and there is the potential in the future for satellite. However, it's not there at the moment. The integrated battery, which is this unit has a 12-volt 2 amp hour or 2,000 milliamp hour battery in the internal here. It has a charger options just like the base station of solar and power adapter, as well as an auxiliary mesh radio option for the Aquacheck wireless probes when available, or also for a backbone for communication to other equipment as well. So for our equipment, you can have different radios internally as well to communicate longer distances. This is a very useful way of doing that. So the bulkhead termination allows the ease of extension for greater range. And what this unit typically functions as is a single station gateway to the online software. It's a very simple way of getting the data online. And for doing irrigation control, it's a good idea to evaluate the full system and look at this. But a good starting point is an RS-300 cellular unit if you're just getting started with it. But if you have plans for expansion, it is a really good idea to go with the RM210. And the reason for that is the RM210 can provide connectivity for multiple stations, has a lot longer run time, and can do more of these advanced control and monitoring scenarios. So this can serve as a single station gateway to the online software or cloud. It's also a telemetry node, so internally it's the same board. If you purchased a cellular unit, it could be swapped and made into a mesh unit. The internals are the same. It just requires a mesh modem, and there's a little bit of service work involved with that. And so this unit can monitor and control and provide a hub for wireless devices. So this is the bottom of an RS-300, and as the standard configuration here, you can see that we have a couple of these hexagonal shapes here, which are the expansion ports, but as a default configuration, this is what it comes with, which is you've got a port 6, which is the RS-485 or SDI-12. It serves as the same functionality as the base station as well. Excuse me, something just happened there. Okay, and then you also have port 8, which is just above, and that port 5, which serves as an analog input for 2 different analog sensors. So you can have flow and pressure on this particular port. Port 8 works as an input for the camera, and then we also have the solar panel that can connect into the photovoltaic port as well. So on the bottom of this unit, you'll see that it has a couple status LEDs. It tells you what the status is of the unit just looking at it, and you can tell if it's running, if the battery's okay, and the system's running and operating okay. So here's some of the options for the expansion. This is what we call a DCL board. This is what can be used to connect internally to an RS-300. You can be ordered with this, or you can add it later. And it occupies 2 positions or 2 holes in the bottom of the RS-300. There's a total of 4 holes or 2 slots. So this takes up 1 slot. And this one connector here provides power to up to 2 valves per connection. Just requires an additional cable. So what this could connect to would be the 12-volt DC latching solenoids or relays. So this is kind of how it would look like if you were to plug that in. And kind of some examples of the valves that you can control. You can also control motors and pumps, but you need a DC latching relay control for that. So a little bit more information that you need to get for that. So beyond just control, you can also add in various sensors. You can add more sensors. So it comes with a base configuration of being able to plug in 2 sensors, 2 analog sensors, or 0 to 5 volt sensors. So you can add up to a few more sensors. So there's 2 sensors per plug on this as well. So per RS-EXP-ING board, you can have up to 4 more sensors per board. With a few more cables and so on and so forth. And this likewise also takes up 1 slot, so you can have a combination of an RX, the expansion for control. You can have 1 of those and 1 for inputs, just as the internal enclosure is concerned. But this adds up to 4 analog sensor inputs. You can have a 5 or 12 volt excitation. You get 0 to 5 volt input, or 4 to 20 milliamp with the use of a few resistors. So you can see here we have the relay on the right, the sensor input on the left, and you can basically configure this and move them around or add as you like. Okay. So with these ports, you can input pressure sensors, air temperature sensors, flow, basically any type of analog sensor. This gives you kind of an idea of some of the different sensors that you can plug in. And then while you may run out of ports, you can also purchase external devices like this, which is an RL200, which can control up to 12 valves or relays. And there's others as well that can be available. So it's just a good idea to look at the needs of your system and plan accordingly. Okay. So let's just take a moment to breathe for a second. I know that was a little bit long for everybody, so hopefully that was good, and you learned a little bit from that. I would like to jump into the online software and review that a little bit as well. While we're just pausing here for a moment, does anybody have any questions that they would like to see, particularly on the system? Otherwise, I'll just go ahead and jump right in. Okay. Great. So I'll go ahead and open up my browser here. Give me just a moment to get that started. We're logging into the online software here and looking at some of the graphs that we were already looking at earlier in real time. Okay, so I just logged into the ranchsystems.com, excuse me, the .com address, and I'm going to click on my account in the upper right-hand corner. And then I've received permission from a customer of ours to show you his site. It's one that's locally local to our area, and we provide direct service for. But there's also other service available. So what I'm going to do is just log into this property and show you what this looks like. So each user has their own user ID and password, whereas you can have multiple property IDs. This is just used for when you connect to the online software, which property you get logged into. And then you can simply jump between the properties in a moment. We also have a mobile device guide for getting started there, where you can see this on your iPhone or your Android or whatever device you have. I'm just going to go ahead and log in. And now once we're here, we've logged directly into the real-time map, and you can see that we have a quick heads-up view, which is a little bit different than most people who like to look at the data. This is the graphical format where we can see the values as they are in the field. Some people prefer this. Some people would rather prefer a different look, which is the dashboard or the heads-up display. But from this view, everything can be accomplished. For instance, you could click on a valve and you can open and close a valve by selecting the new valve status. And then you just simply say what amount of runtime you would like to have for that valve to stay open for, and then click Request Change, and then the signal gets sent to this unit and can open it within a short period of time. So this is a very popular way of looking at the data. You can logically orient it into various polygons on the map. This is just a simple map, a JPEG that can be loaded. You can pick any kind of topographical map or irrigation design map and load it into the system as long as it's a small enough size. And the thing to keep in mind is that most people are using mobile devices, not their computers, so we like to encourage people to use a smaller size map. But let's just take a look at the dashboard and take a peek at that. So the dashboard is considered a heads-up or a real-time look at what's going on in the field. You can see here we have a couple of different temperature sensors. We have humidity, wind speed, wind direction, radiation from the sun, so on and so forth, and then all our different models. So this is just a way of kind of seeing what's going on in the field, and for many people this is the first time view that they come up with. So this is very useful for many people when there's irrigation events to have the irrigation flow here as a heads up so they can tell that the system's on, that the pump pressure is correct, this user is turned on the pump in this time of the year. But we've also defined a few different things for him so that he can turn off the pump in emergency situations and monitor the water flow from the main line as well. Another way of looking at this data is looking at the zone status, where you can actually have preset indicators, and I'm not sure if you can see this here, but we have a few little dashed lines that provide a range of the data that we'd expect. And then when the data falls outside of that range, it changes the color of the indicator. And I find this very useful because from this view, I can click on individual sensors to view that particular graph. For instance, just now I clicked on just one soil moisture sensor, and we have that graph. Or we can click on Show Graph, and this will show the graph of all the sensors that are in that zone. You see here we have the air temperature, and we have block valve status. Let me go back, say 2 months here. So this new graphing function has been released here just a few months ago, and we've been working on it quite a bit. It has a lot of different ways of looking at the data, and it's very flexible. So I'm going to try not to get inundated with it, but it is very flexible. And it's very good to see. So what we can see here is various different levels, no real discerning quality to them, except for if I put my mouse over it, I can tell what it is. So up here in the upper right-hand corner, you can see where it says soil stacked. And what we'll do is we'll just jump into this really quickly here, and you can see what the soil moisture looks like at every single different level, the gallons per minute, the block valves, the temperature. Let me go back to the last 2 months again. Okay. So now you can see all this data together with the flow. This is actually a rain event, so the rain has affected the soil moisture levels. But alongside with all the other alerting mechanisms, you can see how crucial the gallons per minute and then the valve activity is. Not only that you're seeing gallons per minute, but that you can start tying in other sensors, for instance, the soil moisture or the air temperature, to make irrigation decisions and to see the efficacy of those decisions. Okay. So we have a couple of different valves here. Let's go down to what we call the old olives, and let's take a look at what that data looks like really quickly here. So these are zones that I'm clicking on, and each zone has a specific sensors that I've assigned to that zone, but you can configure it however you like. The advantage of this is that when you're looking at a few different sensors, you want to add more sensors in, you can just go over to the sensor assignments, add the sensors, and re-look at this data in a different way. So you're not set at one particular way of looking at the data, and we're constantly evolving this. So as we're grabbing this data here, I looked at the last year. So what my computer is doing right now is actually downloading the last year of data, and then what it'll do once it has that last year of data, it's going to graph it for us. The advantage of this, we have some irrigation events occurring here. So let's take a look at when those were. So if I just click and drag, see, I don't have to wait for it to download again, and it becomes much easier to work with the data. So I'm coming in here a little bit closer and granular, and you can see our irrigation event occurs here. Flow rate, irrigation valve, coming on, coming off, flow stops. Same thing here. We have an inrush, 4.7. Down to 4.2, and we know that this is a good range of values because this grower set a nominal flow rate, and let's take a look at how that looks. So if we go to the irrigation schedules, you can see how we can configure irrigation alerts and control. So here we have the irrigation schedules. You can see the different blocks that he has, and they're separated by color, and a nice little header at the top. Here in the configuration dialog, you can see how we have different feedback sensors and the acceptable range of flow. So we have an acceptable range of 0.2 gallons per minute to 2 gallons per minute after 45 minutes to 20 minutes, depending on what that is, and we select the sensor here. We can also select a master and an injection valve. So we have the particular block valve, so we can turn on and turn off a pump at the same time and give it a period of time to warm up before you open the valve or after you open the valve to open up that valve. You can also select a booster valve or a secondary master valve and injection valve. And by configuring the system like this, when you go and create programs, you now have the option of applying a program to a schedule. So we have a program A here that we just created, and you can see that we have a start time, a number of cycles, and a number of run time minutes per cycle, and pause per minute per cycle. And we have the off times as well. So one of the advantages of doing it this way is that you can work at it as much more absolute way, and you can print this and give this to your irrigation manager and say this is what's going on, and after it's been set, then review it later and see how effective that was. And he can stay on top of that and have that as more of a notification or an alert for him to know that, hey, it's going, and I can go do other things. So it's a very useful tool. So when I take the program here, I can apply it to a period of time. I can also change the weekdays that I wanted to apply in that period of time by selecting the calendar days here. And then we also have a very handy tool here, which is the budget. So if I just choose here for the 18th, because I don't want it to irrigate today, I'd like it to irrigate to the 21st. And we're going to run program A, and we just hit apply a program. And then it gives me a little error here saying this is going to overwrite my existing schedules. I'm going to go ahead and write that there, and you can see here that we just populated those 3 days. So I can, what I can do now is if I wanted to, you notice that there's 2 sets per valve, 2 cycles. I can go in and modify just one of them if I wanted to. I can take away one of these. I can change the time for this one to 2 hours. And it's very configurable, but I didn't have to go in and change every single event. And then all the automated mechanisms like the feedback, the alerts, and so on and so forth were configured in the configuration dialog. So once you've got the configuration set, you can come into the irrigation schedule, put your irrigation schedule together through a program, apply that program, and then the system takes care of itself. You can also simulate the flows from here and deduce how much this flow will create. Okay. All right. Okay, well, it looks like I haven't selected the feedback sensor for this, but generally speaking, what you can do for this is to deduce how much water is going to be applied, how much this is going to affect a particular block. The other thing I wanted to just talk about, I'm going to go ahead and clear the days that I had already put in there. So now we have a clean slate. Is after you've created a program, if you want to irrigate less, so for instance, if you want to irrigate 50% of what you were thinking you had in the schedule before, just change the budget here to 50%. And then hit apply. And you can see here now that instead of having a 60-minute irrigation sets, you have a 30-minute, and it has adjusted it accordingly. It's just changed the run time per valve. Okay, so it's very useful. Lots of different features here, and as you get growing with this particular setup, we'd like to walk the users through the configuration, how this works. It can be very overwhelming, but the tools are here. And we look forward to working with you. And if you have any questions now is a great time. And let's see if anybody has any questions. All right. Well, I'm not seeing any questions here, and I hope I've answered everybody's questions. So I really appreciate your time today. And any further questions that you might have, I recommend sending those to our sales department or your Ranch Systems reseller. Our contact here is sales@ranchsystems.com. and we can get started on something for you and go from there and try and work out a good solution for you and try and take care of all your needs. Also keep in mind that you may have a reseller nearby, so a reseller would be able to provide you some more hands-on approach in your particular area while we service a very specific geographic area. We'd like to work with resellers. So if you don't have a reseller, it might be a good idea to check with us and see if there's a reseller in your area if you need. All right. Well, thank you for your time today, and we will talk to you soon. Take care.